So we're going to look at the second derivative. So by now you should be familiar with working out the first derivative and why we might use this. Now the second derivative is used to determine whether a point is at its maximum or minimum. So we denote the second derivative as d squared y over dx squared. And when this is smaller than 0, the point is at a maximum. When the second derivative is bigger than 0, the point is at a minimum. So you need to remember these in order to answer the following questions. So we're going to have a look at this question. It's asking us to consider the function f of x equals x squared minus 2x plus 4. So in part A, it says by finding f dash of x, show that f of x has a stationary point at 1, 3. Now f dash of x is simply just the first derivative, so we can just differentiate f of x, and that should give us 2x minus 2. We know stationary points occur when the derivative, or f dash of x in this case, is equal to 0. So we can say f dash of x is equal to 0, and therefore 2x minus 2 is equal to 0. Now I can solve this to get my x value, and you find that x equals 1, which is the same as what the question is telling us. Now to find the y value, we simply just substitute this back into the original equation. So we get 1 squared minus 2 times 1 plus 4, which equals 3. Therefore, f of x has a stationary point 1, 3. So for part B, we're asked to determine the nature of the stationary point. Now this is where we need to use the second derivative. So we can differentiate the first derivative, which we can denote f dash dash of x. So it means we're differentiating twice. And that just gives us 2. Now, nature is another way of asking, is it a minimum or a maximum? So 2 is clearly greater than 0, and therefore the stationary point is a minimum. So for this question, we're going to consider the function f of x equals 2 over 3x cubed plus bx squared plus 2x plus 3, where b is some undetermined coefficient, so we don't know what b is in this case. Now for part A, we're asked to find f dash of x and f dash dash of x. So we're asked to find the first derivative and the second derivative. Now the first derivative should give us 2x squared plus 2bx plus 2. And the second derivative, so f dash dash of x, should give us 4x plus 2b. So that's part A done, and we get 4 marks for that. So for part B, you were given that f of x has a stationary point at x equals 2. Use this information to find b. So again, we know that stationary points occur when f dash of x, or the first derivative, is equal to 0. So I can put my equation of the first derivative equal to 0. Now we're told that the stationary point occurs when x equals 2, so I can substitute 2 into this equation and then solve for b. So I should get 8 plus 4b plus 2 equals 0, 4b plus 10 equals 0, 4b equals minus 10, and therefore b equals minus 2.5. So we found b. Now for C, it says find the coordinates of the other stationary point. So we can take our first derivative because that's when the stationary point is going to occur, but now we know what b is. So we'll have 2x squared minus 5x plus 2, and that is equal to 0 because it's a stationary point. So here I've just replaced 2b with 2 times minus 2.5. Now we should be able to factorise this. So we get 2x and x, and we want two numbers that add to make minus 5. So we'll put minus 2 here and minus 1. That seems to work quite nicely, and therefore x is a half, or x equals 2. So if we substitute a half back into f of x, we get our y value is 83 over 24. So the coordinates are going to be given as a half and then 83 over 24. So for part D, we're asked to determine the nature of both stationary points. Now we've already worked out the second derivative, so we're going to use that and just substitute in our values of x. Now remember, we have worked out b, so it's now 4x minus 5. So I substitute in a half, so when x equals a half, we get 4 times a half minus 5, which is equal to minus 3. Now minus 3 is less than 0, therefore this is a maximum. And we can do the same with x equals 2. So that gives us a value of 3. Now 3 is greater than 0 and therefore it is a minimum value. So in this video we've looked at the nature of stationary points and whether these are maximum or minimum points using the second derivative.